Hi everyone, thanks for joining us today for our monthly Fetzer talk. Sorry, I'm on the wrong slide here. Good start. I'm Justin, co-founder of Fetzer, along with Skulk, who unfortunately can't make it tonight. But I will just do a quick introduction to Fetzer. If it's your first time, Fetzer stands for Front-End Development and Design South Africa. We were originally just front end, and we used to work with ZAPD, the South African Product Design Network, and then we amalgamated the two to form Fetzer, and we do all design and front end activities, meetups, talks, and so on under that banner. We are a registered nonprofit, and we've been going now for 14 years, so long time. And yeah, thanks to everyone who always joins us and supports our initiatives. I just want to thank our sponsors as always. It's they allow us to keep the lights on, so to speak, pay the StreamYard subscription so we can bring you these talks and various other sundry things. So thanks very much to them. Our sponsors are KRS, a software development company that joined us as a sponsor towards the beginning of this year, and they largely sponsor our newsletter. If you don't know about our newsletter, we have a bi-weekly newsletter that goes out with interesting links related to front-end and design, job postings, links to our previous talks on YouTube, and so on. I'll post the link to that in the chat towards the end, so you can sign up for that if you want to. And then we have two other long-term sponsors who've been with us for a very, very long time. NML, I must make a disclaimer, I work at NML, a software development company in Cape Town that's been going for about 18 years, work largely in the fintech space, and IO, which is also a software development company based in Cape Town that largely works with startups. Yeah, so thanks very much to the sponsors. As I say, we couldn't bring these talks to you without them. Of course, we also couldn't bring these talks to you without very generous people offering their time to give us talks. And tonight, I'm very happy to introduce Jonathan to you. Jonathan is going to be talking to us about debugging web performance. Bit of a tongue twister, but there we go. We're very grateful to him for joining us tonight, this evening, and I hope you find the talk very useful. I'm sure you will. I'm going to hand over to Jonathan, and he will introduce himself and get going with the talks. Yeah. So thanks very much, Jonathan, and over to you.
Awesome, Justin. Can you hear me fine?
We can hear you fine. As soon as you've done your intro, I'll make your presentation full screen.
Perfect, no worries. Okay, cool. Again, yeah, thanks, Justin, and thanks just broadly to Fetzer. A really good thing you guys got going on here. So thanks for the labor of love. To all of you guys who joined this evening as well, thanks for your time. Yeah, so just a little bit about me. I've been in sort of the design, development, software engineering space for the better part of maybe 12 years now. Had quite an unconventional journey, starting out as a designer, moving into UX, front-end development, and my latest tenure was actually just as an engineering manager. So all things considered, as unconventional that it was, I've kind of been able to see quite a broad perspective of things around insofar as performance is concerned. And yeah, I hope today is just a good time of learning and exchange, and open to any questions and QA. Hopefully we can do at the end as well after we go through this. Okay. One thing, when I'm not sort of just diving deep into actual web performance topics or nerding out, so to speak, I am a full-time husband, a lover of fish and chips, and yeah, a budding photographer. I love light and shadow. I love dabbling around in music as well. So I think that's also a pastime and creative outlet. And yeah, no pain, no gain, right? So I do some time in the dojo as well with martial arts. Love that as well. Okay. But yeah, thanks again for your time today. So we're going to kick it off. And hopefully you definitely find some value. Okay. I think before I start though, Justin, maybe you can even help me as well. Is that it would be good to know like who do we have in the room? Again, it's important for me that irrespective of where you are in the value chain, product manager, designer, developer, that there is something you can at least take away. So it would be good for me to know maybe. So I don't know, by way of maybe we can see, maybe it's the
I'm going to
best way we
ask in the chat.
Sure.
Okay, I just sent a message to the chat. If you are joining, can you maybe just type, who you are, what you do, what your interests are, and we'll see as they come through. Hopefully they do.
Yeah,
I know the people watching. Okay, thanks, Tess. Tess is here. She's a product designer. Thank you, Tess.
Awesome.
Okay, while we're waiting, I know there are more people there because I checked. Wow, we got Tommy's here all the way from Seattle in the USA. Hi, Tommy. Nice to have you.
Welcome, sir. Welcome.
Okay, everyone seems a bit shy. While we're waiting for more people, I can say what I do.
Yes, go for it. Yeah.
I'm head of design and front-end at NML, and I run both the UX UI team and the front-end development initiatives.
Awesome.
We've got Nkosana, student at We Think Code. Nice. We've got a mobile engineer watching the stream from LinkedIn. We've got a retiree looking to upskill in AI. Okay, so we've got a really nice,
fantastic,
broad,
that's good.
Broad representation there. Yeah, anyone else who's there, feel free to post in the chat and.
Awesome. No, that's great. But I think thank you guys for. It seems like there's a lot of diversity in the audience as well, multifaceted crowd. So that's great. So, yeah, we're gonna hopefully, even if we touch on some technical topics that is maybe out of your domain or vice versa, hopefully there can always be something you can take away from the talk. Okay.
Yeah, let me just reiterate. Sorry, Jonathan. As we go, please just type your questions in the chat. Whether you're on LinkedIn or YouTube, they do come through to us in the studio, and we will address them all at the end.
Fantastic.
And I will now be quiet. Thanks, Jonathan.
No, awesome stuff. Great stuff. Okay, as with all talks, and just note this is my first one, so any feedback at the end is very much welcome. Radical candor for the win. I like to set the stage with a story, and I think it's great. I love thinking in analogies and hopefully having stuff that are relatable for all of us to chew on and debate as well. So I want to welcome you to TechMart. They're a new player in the African e-commerce space. They just launched their new website after a long graft of 8 months and about 3 million in investment. They got away from their 960 pixel grid to a proper parallax website and all the bells and whistles, and they're very proud. And on launch day, this was kind of the atmosphere. Definitely one of just elation and euphoria. Unfortunately, 1 month later, this is the picture we see. Maybe something you can relate to, but voice of the customer always front and center as always. We had Tundi that made a comment that the page took forever to load. She gave up and just went back to Takealot. The analytics team talked about their mobile bounce rate moving from 34% to 78%, basically doubling. Another person talking about the actual page jumping around while they're trying to click, and they actually bought the wrong product by mistake. Revenue's down from the finance side, and we've got another customer just saying it just feels sluggish on their phone. And obviously what sort of subsequently happened after this was a common trait and verbatim in the room of it feels slow. This was the common sentiment. Obviously, we moved then into opinion-driven development after that, post the issues, and the UX analyst actually asked if you could just use the loading spinner, because from their sense of meeting the visibility of system status heuristics, that can work well. Visual feedback, of course. The designers were big on maintaining high-res imagery and premium animations, as those are integral to the brand experience, so we cannot touch those. Backend team was quite defensive, saying the front end is sending about 200 requests on page load. The poor front end devs, I mean, they just following the Figma design, right? So what are they supposed to do? They just implement what they got, what they were expected to do. And the product manager on the great MacBook M4 Max Pro machine found out about an awesome tool called Lighthouse, and their score was 90. So all things considered, things are working quite fine. Ultimately, what becomes then the solution to every performance problem is the loading spinner. So yeah, probably a relatable story that we'll try and maybe address as we go along. But today we're going to try and move away from that and actually get to a place where we can get a foundational sense of web performance fundamentals to empower us all. Get some sense of workflow, as sometimes knowledge in isolation is great, but when applied in a process or across a lot of teams, it can be a difficult thing to instrument and implement. And then we're going to try and also be a bit more practical with actually using the dev tools to maybe unpack a bug or two and kind of see how practically that can work out. Quick note, this talk is not about SEO rather. Users leave slow slides regardless of where you rank. And yes, I want to sort of note that page speed and so forth does play a role in the search algorithm, the ranking factor on Google's side. But today it won't be about that. It will really be looking at sort of performance as being a good thing to do for your end users. So hopefully you guys agree with me on that and align with me, and we can sort of try and get to a better user experience at the end of the day. And again, I want to reiterate, the title was, you saw Primer. Primer is definitely where we need to be today. It's definitely going to be a lot of breadth and not too much depth where we can help it. Because as you can see, this topic of web performance can span a millennia. So yeah, Justin, depending on how this goes, maybe we'll even have a part 2. But for today, we'll go for more breadth in depth. Okay, cool. If we look at now the whole aspect of it's slow. This actually dates back probably about 40 years now, to a little place in the States where there were a couple of guys at a place called Xerox PARC, who were kind of the founders of some studies that kind of set off the movement for sort of human-computer interaction, right? And they actually put together a paper called The Psychology of Human-Computer Interaction. And what they endeavored to do was to say, okay, you've got a computer that retrieves data and processes and stores data, but can we find an analogy that kind of gets replicated in our own biology, right, in our brains? And what they came was their own sort of abstraction, effectively. They looked at sensors, sort of on the left, inputting into a couple of processes, be it perceptual, the cognitive, and the motor processor. And effectively what they deduced here, insofar as slowness is concerned, is that the threshold where humans notice delays is about 100 milliseconds, right? So any studies basically from that time in 1983 that has sort of underpinned a lot of stuff that maybe you guys have heard about, like Fitts law, or maybe some of Nielsen's heuristics around status feedback or response time thresholds, have all been underpinned by this core study that was done in 1983. So I think a good thing to know is that moreover just trying to solve for performance in the workplace or with your own product design or your own development needs, this is actually something innate to us as humans where we notice delays, and it's something we should probably care about. Why else should you care, would you ask as well, maybe subsequently? Well, here's an interesting thing I picked up. This is from sort of some stats I picked up in September. And in Africa, we need to do more with less. Compared to the global average of about 91 megabits network speed, Sub-Saharan Africa sits at about 14 megabits per second. South Africa, in this case, which I'm assuming maybe predominant of the audience is from, I'm assuming is about 35. But effectively, we don't have much of the bandwidth that the rest of the world does. So in so doing, we really need to be a bit more empathetic, I guess, with how we sort of consider any design development decisions. Another interesting thing I pulled from a study done by OpenSignal is that even currently, right now, if I sort of cast your attention to the right, we've got over a lot of people, even with Cell C, I'll take one, about a third of Cell C connections remain on 3G. Look at big telecoms like Vodacom, 18.9%, and about sort of 13% apiece between MTN and Telkom. You guys have probably heard that by end of 2027, there has been talk about sunsetting the 2G, 3G bands to move straight onto 4G. But with that said, we still live in this sort of situation as well. So another reason why we have a lot of people, not only in South Africa, but in Africa as a whole, that are still very much on mobile network and slow bandwidths. So it's something we should probably consider, especially as we build our products. Okay. Right now, obviously, we can have a lot of the why and the underpinnings, but before you can optimize, you need to be able to measure something, right? So you effectively can't optimize otherwise. Or it makes it, rather, you can try, but it makes it hard to actually see some tangible results. So one thing that some of you may be aware of, and again, for this talk, I'm not making too many assumptions as a primer talk. We've actually got this thing that is called the Core Web Vitals. Think of it as a set of metrics that allows us to sort of understand web performance and where to optimize for what things. This was actually introduced by our friendly friends at Google, who started probably way back, I think even pre-2020, putting this together. And those various studies from 1983 that you've probably now sort of heard of, that we've gone through, has informed a lot of the thresholds that you see as well with this Core Web Vital metric framework. And there are three verticals effectively that are looked at when it comes to Core Web Vitals. Number one, we look at loading, or rather, how fast does content appear on the screen? Let's say when I load the website. Also, we're looking at responsiveness, i.e., how quickly do interactions respond when I click? What's the response time? And then visual stability. This literally talks to stability of a page. If I'm actually navigating on a given page, do I have a lot of dynamic elements fighting for attention and sort of creating a lot of shifts in the layout, making me click on the wrong thing? So these are sort of the three things that underpin Core Web Vitals. The specific metrics now are what we're going to actually look at, just for more understanding. On the loading side, we've got what we call LCP, or largest contentful paint. And what this effectively looks at is a measurement that Google does, where it actually has an algorithm that measures the point where the page's main content has likely loaded on your page. So not like an ounce of a pixel, but it's trying to infer, okay, a hero image has loaded, so I guess the person is actually on your website right now, and there's something to interact with, right? And there's, for all these vitals, there are thresholds that Google sets. For something like LCP, as you can see, anything that takes 2.5 seconds and below to load is a good thing. 4 seconds and above, that's quite poor, okay? Some things that can hurt your LCP score, just at a high level. If you've been lazy loading a lot of hero images that sit above the fold, images, videos, that's a bit of a no-no. If you're hosting a lot of those important images above the fold, let's say in another CSS file as a background image, that makes things hard. And I don't know how many of you are still using this, but using an image tag to host the image within an SVG element, that's also quite a bad thing. The next one we're going to look at now is INP, and this specifically translates to interaction to next paint. And what this is doing now is actually looking at the responsiveness of the interface when any user clicks, taps, or does any keyboard interactions. effectively what it's doing is that if you sort of do a mouse click, it's looking at the time delta between that click and when there's been sort of another visual state update on the given page, right? For this one, the thresholds, again, to sort of that threshold of instantaneousness, so to speak. Good is perceived at 200 milliseconds or less. Anything 500 milliseconds and above is poor. I think I like to relate INP as well to those of you who are probably gamers or budding esport enthusiasts. If you guys are playing stuff like Counter-Strike and Call of Duty, you'd probably want a very low INP, especially when you're doing battle there, right? So I like to sort of contrast with that. Stuff that kill your INP score. If you've got a lot of like event listeners, like click handlers, scroll handlers, doing a lot of work, that can actually prevent the browser from having a good INP sort of response time. And any long JavaScript tasks, especially a lot of synchronous code that has to run concurrently, or rather in a sequential fashion, that can also hurt that as well. The third one, looking at now visual stability as the last core web vital. This is what we call CLS, or cumulative layout shift. And all this is really doing is looking at any unexpected layout shifts that have happened during the course of your interaction with a page. Now this one, unlike the other two, is not really measured on sort of a time scale of milliseconds or seconds. It's more of it's actual formula where they sort of two things that kind of get multiplied out and they equate to a given value. So without getting too deep about that now, at least for now, just understand 0.1 as a value and below is good. 0.25 is poor. Stuff that kill a CLS score, maybe having a page load and then suddenly injecting a bunch of content randomly without the browser kind of being aware of this, or the dynamic content that pushes other things down, that hurts CLS. Even a simple one like having an image with a source tag without any explicit width and height attributes. I've seen this mistake a lot. That can actually be something as well that is can actually hurt your score. So in aggregate, what we can see is there now, in terms of the top three core web vitals, or the core ones rather, are your LCP, INP, CLS. And I think just for good oversight, it's good to know that there are some supporting metrics that underpin those, or rather, if you optimize those, they have kind of a net gain for your vitals above. And those ones I just want to sort of highlight are FCP, or first contentful paint, right? So that's when anything appears on the screen, even any pixel, right? Time to first byte, that's more on the server side, how fast you get a response from the server. And then total blocking time, basically the time it takes before your browser is loading something, between that time and the time when you can actually be interacting with elements on the page. That's your total blocking time. Cool. Now that we kind of also have sort of a framework to use, I think another thing that sort of ties into where it becomes very important for one to get to a process is to understand this distinction between lab and field, right? And we'll go over those briefly. So look at lab as something whereby you are collecting data in a synthetic or controlled environment with predefined settings. And your field, or some of you might know this as RUM, or real user monitoring, we are actually collecting data from real visitors in the wild that is using your site. They might be using various devices, network conditions, right? So it's not as predictable, but it gives you a more realistic account. In short, if there's one thing you take away, just know that the field or RUM data is what you want to trust, right? Lab has its place, but field is what you trust to understand what your end users are experiencing. If you look at something like what an example of a lab sort of audit, if you will, is something that you guys might have seen. If you open up your browser and the DevTools, you'll see a tab called Lighthouse. In this case, I just pulled up amazon.coza, and I actually I ran a simulated audit on a mobile device, and I got a score. And again, this was simulated on my MacBook M1 Pro based on conditions that DevTools have given me as a pre-configured way to see something, a sample size of 1, if you will. Contrast this now with the same URL with something like Page Speed Insights, a website you can also visit today and check out your production website if you want. And the scores are vastly different, as you can see. And this is notably because now this is actually a 75th percentile mean or aggregate of all mobile users over 28 days on various network speeds and compute on their mobile devices. So this is sort of where we'd want to sort of look at first to see what's really happening out there. And then think of the lab data is then what you use when you're trying to simulate or diagnose a given issue, right? Some stuff you guys might have seen in terms of field data as well, or the real user monitoring RUM. For example, a tool like Sentry, there are a host of others, Datadog, Debug Bear, the like. But these are tools that you can actually sort of deploy your application on to observe your applications rather, and actually then kind of see the 75th percentile aggregate of what your common use cases are for your end users. So a tool like this would sort of have this built in if you invested something like this. Another thing I want to allude to is something called the Crux or Chrome User Experience Report. This kind of takes public data from Google for the users that visit Google, and you can actually punch in your website today as well and kind of get an aggregate of the various screens or origins of your website to see how you're doing as well. So definitely one that you can surface. Note that this is only for users that use Chrome as a browser, and it's public data as well. A cool thing I also wanted to add on is that very field metric now that you saw from the previous slide is that you can also now in the DevTools, probably over a year now, you can import this, or rather you can import this into your actual performance tab to actually contrast your lab data versus your field data. And I think that is something that's great for us to quantify what's happening on my machine versus what's accounting for really out there in the real world. Okay, now with lab and field sort of out of the way, the next thing I want to sort of transition to is to understand how to get towards a workflow. Because I often know, and in teams I have been in, we usually have a lot of siloed conversations. There's product managers on one side looking at a customer satisfaction dashboard or a user funnel. And then you've got the engineers on one side looking at real user monitoring data and response times and round trip times. And those worlds often never coalesce, which makes sometimes the legwork or the effort to get things improved and over the line that much longer and that much harder. So this is what we're going to try and maybe do, at least in a basic way, to see how you guys can maybe put a workflow for yourselves together. Okay, there are three parts effectively: instrument and identify, diagnose and fix, and monitor and prevent. If you look at the instrument and identify piece, something that you guys actually can use today in your code bases is a JavaScript library just called Web Vitals that's maintained by Google, the Google Chrome development team. And you can actually today actually just import that as a library in your code base. You see it on line 2. Line 5 there, we can actually grab some device context of our actual devices that we're on and actually capture that. And sort of, let's say we can, if you're using something like Google Analytics, you can track the performance. A lot of you are probably trying to maybe do a breadcrumb of events, page loaded, product card clicked, etc. You can have those events and you can bind actually these core Web Vital metrics directly into those performance functions. And when you persist them, in tandem, you can then persist them as well to your RUM tool. Let's say we're using Sentry. And then what it allows us to effectively now is actually evaluate funnel stats actually against the RUM data in the end to actually properly prioritize which problems need our attention. So in this case, what I've done is a simulation. We have across our various journeys, which I think is always important to do. Never just take a snapshot of one page. Look at a funnel. Let's start from a home page to a checkout. And then you can actually bind the core Web Vitals to each of those steps. And this becomes then something we can evaluate against our field data or RUM data to actually understand then what's the root cause and diagnosis. But it's again some key priority of what's the key cause of a given bounce rate, for example. So that I think that makes it a bit more valuable than just sort of clutching at straws and trying to fix things as you go and hoping for the best. Right. So that's definitely something you can try. From a diagnose and fix perspective, now noting that we've prioritized our core fixes from what we've ascertained from the data, we can now actually do something like go into Lighthouse on our local machines and actually run some tests that actually, at least at a high level, give us a sense of where to start looking, of where, effectively in this, in a nutshell, where things are red, that's probably where you need to be trying to improve things, right? And then subsequent to that, once we have the Lighthouse stuff telling us where we actually need to be looking, the DevTools Performance Panel becomes that place of actually deriving core insights that gets us now into the nitty-gritty of what exactly is going down under the hood, so we can actually make the requisite fixes to fix the given issue. And then I think lastly, just as part of continuous improvement, or rather being a bit ahead of the curve, is kind of this idea of understanding we want to be able to monitor and prevent. Best case, not even having these things happen in the first place. And what you can do is, like a lot of you probably have pipelines set up with your CI/CD pipelines. A key thing you guys can do as part of developer workflow, before you run a commit, you can use a local Lighthouse library as part of a Node CLI tool. You can run it on key pages, test it on your own on a given list of throttle networks that are maybe key for you. Before you merge, you can actually run sort of a CI/CD sort of script, or a job rather, that actually can automate Lighthouse scores and even enforce some performance budgets for, let's say, a LCP or CLS threshold. And then I think notably after that, after you deploy, actually having some schedule systems that maybe set up some alert threshold on key user journeys that are problematic, and maybe weekly performance reports, so you guys can actually be proactive ahead of the curve before these issues land up as a customer satisfaction issue or a verbatim from a hellopeter.com, right? Okay, I think before I carry on, I just want to note at the are there any maybe key questions or maybe stuff that is not maybe Justin that has maybe need some further explanation, or how are we doing?
No, we're good for the moment. Yeah, we can carry on, and then we'll take questions as soon as you're ready.
Okay, great stuff. Okay, cool. So now we've got a understanding of the metrics we can use. We've applied them now into a framework of instrumenting, identifying, diagnosis. But now we actually want to move towards a place of the diagnosis, which is a core part of today in using this performance panel. But before we can go there, I think it's important to know we need to at least take a couple of minutes on the browser. Again, the browser is the common denominator in all these issues. Any of you building web applications, especially, you are constrained or benefited by the browser, right? So it's important we have an appreciation for all the things it does and where we can sort of leverage the best practice effectively at the end of the day for our needs. So again, note it's a primer talk. We cannot go through the entire browser architecture, but I think this picture should just give you maybe a great sense of the behemoth that it is. It's effectively like an operating system. I like to think of it like that. But we can just touch on maybe some core essentials just to help us better understand things. So when we get to a debugging stage, there's a bit more of a visual picture in your head of how things work under the hood. The first essential we must understand is that of what we call the critical rendering path. And in a nutshell, all this means is that from the time you load a website, when you download that first, let's say, HTML file via network request, to the time the browser actually paints the first pixels on the screen, it has to go through a series of steps to get there. And there's a few of them, right? At a high level, I want to just sort of walk you through this, and I think it will also, again, just open our understanding of a lot of the things that the browser has to do under the hood just to get your UI to show. Okay, so top left, we can just walk through this. Basically, you got a network request that will get, let's say, some HTML, some maybe relevant CSS or JavaScript. It will take from the network request, it will go through that HTML file, So all your tags that you've got listed there, it will parse those and build what we call the document object model, or the DOM tree, which some of you might be familiar with. And it sort of gets a data structure of nodes together. It then looks at the CSS and it builds a complementary tree on the side, which is the CSS object model, or CSS OM. And that comes usually from your CSS style sheets. So you've got the HTML and CSS. And finally, we have our JavaScript, which again is quite of it's a blocking operation, because as you guys probably know, JavaScript can run logic, but it can also influence your HTML tree and CSS tree. So this has to be executed as well. And then that render tree, that is the final form, if you will, has to then go through a style calculation. So this is where now your classes are applied to HTML elements, for example. It then has to actually compute the geometry of where these things need to be positioned, let's say on its X and Y or Z axes on the screen. And then finally, once the geometry is sort of computed and built up, then we actually need to paint. So now that's where actually the browser needs to take those elements, draw some bitmaps, and hand it over to what we call the compositor to combine all of those things and actually display them on those on the screen as well. So a couple of things happening there, but well noted. Something to note also, maybe after that, a different way to look at it, a lot of this stuff needs to happen in a very linear process. And I think take a snapshot of this visual, but you'll probably see it come up a bit later as well in the slides. Another one we want to look at is network resource priority. And the understanding here that we just want to take away is that when the browser is requesting resources from the network, be it an HTML file, a JavaScript file, a CSS file, images, it actually has a priority that it gives to certain things to know what to get first, right? And that actually moves from like a series of critical to low, right? So at a high level, look at any sort of, for example, CSS or JavaScript that's sitting in that head tag, that is seen as a critical render blocking step. When we say render blocking, that the page will not show anything until these stuff are pulled, evaluated, and executed. High priority, if a lot of you guys have like Google fonts that are in your head tag that you're trying to pull in, or stuff that you've defined as a preload resource that's urgent, those are given high. Images by default, unless otherwise changed, are defaulted to medium priority. And any script maybe that you've added like an async attribute to, that is also noted as medium. And then low priority, that is where we see stuff that we've deferred or stuff that are sort of off screen or not in the current viewport at the moment. Those can be low. So it's good to know that the browser actually has a bit of a priority queue, if you will, in how it actually pulls in resources. Another key understanding as well now as thirdly is that of the main thread. And basically all this basically serves to define is that there's also a clear order of what to execute. So even though we've got all of our network, maybe files or resources, there is actually a highway, if you will, of tasks that the browser needs to do. And it can only do that in a very sort of linear way, if you will, right? At least natively. And this sort of ties back to some knowledge that you might not know, but JavaScript, unlike a lot of other language that some of you might have used, is single-threaded. So by single-threaded, we are saying is there's one highway. Everything has to go through this one highway. And we cannot multitask. So we need to actually try and get things done in an actual sequenced order, right? So maybe something for you to see as well. You don't have to spend too long here, but there's actually a priority queue as well of what tasks the browser will look at. If I look at the right, effectively that spans sort of from top to bottom. You have your what you call synchronous code. So if you have like a console.log and a bunch of them in a code block, that synchronous code will run first. We then have our micro tasks. So anytime when you guys have used maybe a promise or asynchronous code, those run directly after that synchronous code. It's sort of second in precedence. Any sort of key rendering for callbacks, like request animation frame, those actually take place after those micro tasks. Then the browser can paint something to the screen. And then what's left for last after all those are done at the top 4 is sort of your set timeouts or stuff that we say are usually queued as well, right? And a good example, if you look to the left, we won't go through each line, but sometimes what you can naturally think for the untrained eye is that these stuff just execute in some sort of line by line order when it's not actually the case, as you can see by the numbers defined. Our console log start, and then we have our promises, then our request animation frame, we paint something to the screen, and then our set timeout at the top is what actually runs. So a good thing to understand this, especially when you're debugging and not understanding why certain things are executed in what order. Again, to reiterate, it's a 1-lane or single lane highway. So your fast task can zip through. If you have slow tasks, they will block everything, right? The main thread has to do one task at a time. So if you had a big truck that blocks all the little cars behind, everything has to wait, okay? And then also notably, a thing that's usually big, especially when we talk to anything visual on a screen, some of you are maybe gaming or even watching TV, is frames per second as a concept. And so far as the browser concerned, it strives to deliver 60 frames per second, which means to get 60 frames in a second, you need to deliver a frame every 16.67. And which means is that 16.67 milliseconds that you have is the time the browser has to do all of the above. If it has long tasks that it has to wait for, it effectively leads to what we call jank, where you guys have seen very sluggish or stuttery animations. That is because there's a lot of work going on the main thread that is blocking the actual paint schedule for the browser. Okay, with that said, hopefully those essentials out the way, it's time to get to the flames. Okay. And Justin, I think just hold me also honest, like if there's any other questions or important ones. Otherwise, we'll just keep on moving on. There's no worries.
Yeah, carry on. Sorry. Cool. Carry on.
Cool. So now to the flames, like I like to say. And what we're going to try and do now is actually moving now towards this performance panel, noting some of the underpinnings we've learned, and trying to get a bit practical on this. So, reading a flame chart 101. And yeah, I think just also let me know if there's from the forum or the attendees, if there's anyone that is maybe not seeing the screen. I'm happy to zoom in at various places if need be. But you can, I think we can just you guys can just let me know. Okay.
Yeah, I think it's fine for now. We'll let you know. Thanks.
Sweet. Okay, cool. So first, I want to just deal with how we get here. So you access the performance panel in the Chrome developer tools, right? So this is the Chrome or Chromium browsers, where you can actually see a tab called performance. And usually you can run what we call a trace or record a trace and see a lot of these things that you are seeing on the screen right now. I first want to just deal with the colors so we can get that out of the way. So at a high level, whenever you see yellow, think of that as any scripting task, be it, and especially that's JavaScript. So anything we are calling a JavaScript, maybe a library file for Google Tag Manager, or actually evaluating and executing JavaScript, that's yellow. Anything to do with layout calculating, not the painting, the actual calculating the geometry and rendering, those stuff live as purple. So CSS, that triggers a layout of the screen. Anything that changes the interface from a rendering perspective, that's purple. Once the layout is calculated, the green defines the paint. There's now painting pixels to the browser. And blue, not so few and far between, but predominantly around any loading activity from the network. We are waiting for sort of some action to happen, and very much always there when you are pausing your HTML after you requested your HTML file. Okay. Now, the network tab is what you see at the top, firstly. And again, we're looking at this timeline left to right, and over duration, you can see what the network is doing in terms of requesting, for example, an HTML file in blue. And let's say we go to yellow, we are getting some scripts from, let's say, GSAP, that's an animation library, and our CSS. And you can even see from this very network tab, there are some stuff that can be done in parallel, right? So see it as a timeline of all network requests sent and downloaded by the browser. At the bottom, again, mapping up with the same time, is the actual main thread. So remember the highway I talked about earlier, right? These are now the tasks that are happening in a clear sequence, and it's feeding a lot off from the network tab above, i.e., you could have a file that's pulled down from the network. Once it's downloaded, the main thread gets to work in evaluating it, executing it, and so forth. But as you can see, it's a very much sort of a very synchronous linear process that is moving from left to right, and the main thread has to do all the work effectively at the end of the day. Another one I want to point you to is that on the performance tab top right, if you click the settings cog, we spoke about lab tests earlier, right? So that is actually where you can control things like the type of CPU that you want to sort of emulate, be it a desktop or lower end mobile device. Also, you have the network drop down that allows you to sort of simulate different networks, 4G, 3G, 2G, the like. And then a cool thing that the DevTools has actually recently introduced, and by recent, I think it's actually over a year as well now. You guys can also, I stand to be corrected, but it's been around for a while, is that now when you look at this chart, before this insights panel on the left, you were kind of just left your own devices to kind of triage and look at where things are. But now what's great is that with the core web vitals of LCP, INP, and CLS, we can see the insights panel actually gives us breakdowns of where to look. And if you spot even carefully, yes, it has happened. There's actually now ways to actually debug via AI, which we won't spend a lot of time today, but it's great that this is there just to speed up the diagnosis process. Yeah, but effectively, Insights panel helps you spot the core fixes to look at. Okay. And then just lastly, when you see sort of these red diagonal lines, remember we spoke about that blocking work if you're not within sort of a given 16.67 millisecond frame count to meet the frame. Those stuff are deemed long tasks. So effectively, any task taking more than 50 milliseconds is defined as a long task. And what you should be taking from that is we either need to let this task not block what I'm trying to do in the browser whilst experience some stuttery animations, or we need to maybe split up or batch up this work. That's your long task. And then lastly is also just looking at a given task. When you look sort of from top to bottom, this cascading call stack or call tree, if you will, that is just defined as the current tasks that are running and maybe the subsequent functions or logic that is running in your given code block. So this allows you to see how deep the call tree goes. And obviously, once that compounds, it makes a long task at the end of the day. So something to be aware of. Okay, so with that out of the way, reading a flame graph, or actually I like to say an icicle, because it is kind of inverted. I think it's time to get our hands dirty with a couple of things. Okay. So we're going to have our case study, and we're going to assume now, or rather role play, and assume that we've been now hired as performance consultants after this bad revenue downturn for the TechMart exec. And we're going to try and help them fix some issues to get their site a bit more optimized for their users. Okay. You can have a look at this, our sort of our, by all things considered, pretty website with enough negative space, but it's riddled with issues, as we'll probably see soon. Okay. So quick disclaimer as well. This debugging part of the talk will not be going into very framework-specific work. So whether you're using stuff like Svelte, React, Astro, we're not going to focus on framework-specific things. Happy to maybe talk about a couple of things in the QA section, but we really want to sort of underpin some fundamentals that are agnostic to whatever framework you use at the end of the day. So just know that these same principles can be applied, albeit that those frameworks might just do it in a different way, syntax-wise, or even automate those processes for you. Okay, just good to be aware either way. Okay, So this is kind of what we received from the TechMart analytics team. What was kind of nice about this is that we actually had some field data that they actually had instrumented for us. So thank you for that, team TechMart. So they actually went through like about 800,000 sessions on our RAM tools, and they were able to divvy up the users into about 6 cohorts based on device and network. So we can see sort of on the left, our user cohorts, we've got some people, albeit small, it's probably our developers that were maybe deving and deploying using a sort of a MacBook Pro, right up until a rural mobile sort of device, which is sort of something we were seeing as our mobile Galaxy A1 running on 2G, 3G networks with like download speeds of 3.5 megabits and a lot of latency as well. We can also see that, broadly speaking, we are failing across the board. Yes, we have some great LCP scores up top for the first two, our dev MacBook and our budget laptops, but we still got a lot of traffic coming down from our urban mobile users and below. So what this data has helped us ascertain now is that there's actually stuff to fix. The idea being, if we fix things for the lower end, definitely we will see those fixes trickle back to the top as well. Now, here's a great tool I also want to introduce you to guys introduce you guys to, and that is the Lighthouse Node CLI tool. So you could see earlier we were using Lighthouse in sort of a browser context in a Lighthouse tab. You can actually get a Node CLI tool that you can run in your project, run local tests. And the great thing about this is you can actually set up a lot of configurations that allows you actually to then do a bit more of a granular setup, if you will, that kind of marries more tightly to the cohorts that you're trying to address issues for. So you'll have something like this, for example. You'll have a Lighthouse CLI config. In this case, we are writing up a config for a desktop form factor. We're setting up some throttling configurations for network speed, and we're emulating a screen. For example, it's not a mobile device, more of a desktop, and even the type of compute power that this device has, right? So what's great about this now, against those field results that our analytics team gave us, and which we now made complementary profiles for, we can actually run this locally. And once we run our test now, we can see for our dev MacBook, we had a Lighthouse score of about 77, doing quite abysmally on our budget laptop. And as you probably suspect, once we get to sort of rural mobile, we also get bad scores. One thing I want to just note about this as well, when we look at Lighthouse scores, at least at a high level, these are relative. When I say relative, is that there are specific performance criteria given to desktop form factors and mobile form factors. Simply said, or simply put rather, Lighthouse sort of demands more from a desktop device versus a mobile device. So it kind of weights out the averages accordingly. That being said, in terms of stuff like largest contentful paint and CLS, they are very much in the red for many of them. So there's work we can definitely do here to move now into a diagnosis phase. Okay, so now we've got our field data. We've correlated some simulated lab tests against those cohorts. Now we can jump in and see what's going on. Okay, the first thing we're going to look at, and this actually came from a customer verbatim, simply asked, why is the page blank for so long? And we know when something's talking about load time before anything happens, there's usually a avenue to look at LCP scores, right? So we've kind of seen on our lab test, we had about 8.5 seconds of delay. That's way too much. So let's dive into sort of the code, and let's see what we can maybe optimize from this point. So first step always is, when you open up your DevTools, open up the performance panel. Remember now we don't have our CLI in our application code. So we can actually go to the right in the environment settings step and actually add those custom profiles that we want. And that will be basically the network conditions, as well as a type of slowdown CPU, just to mimic the type of hardware that we want to test. In this case, we're going to look at a mobile device at a 6-time slowdown. Again, for context, I was testing on an M1 MacBook Pro. So your guys' slowdown might be different when you run things on your side. But basically, we set up this throttle configuration. We go to the top left, hit record and reload, and we record a trace. The trace loads, and what do we see? First, there's just a big green block. And if we highlight that green block, that's actually a photo image that was downloaded. It took about 7.15 seconds to download. And to the right, if you can see that yellow block, the LCP delayed as a result by about just 8 seconds, which basically says that for an image to display, right, it takes that long to download. If we look further down as well, we can see we actually, once we click on a given tab, there's a summary tab that appears at the bottom. And what's interesting to note there is that we've got a 5120 pixel width image at 100% quality, which is possibly overkill for this mobile device. And further down, we can see that this request was initiated by a file called hero.css. Okay, let's go a bit deeper and maybe see what's going on under the hood. Okay, interesting. So you click on that hero CSS sort of initiator file. It takes you to the sources panel, and we can see that we actually are loading two quite big background images. Now, from our context that we heard earlier with the design team, we know that they were kind of big on having high resolution imagery and a lot of immersive animation effects. So this is probably a telling sign as to why this was happening. So one issue that we can see from this, though, as we learned probably earlier, if you're trying to have a low LCP score, you should make sure those above the fold images are very easily discoverable by the browser. By stacking them in a hero.css file, what you basically told the browser to do is find the CSS file, download it, go through the CSS file, find images, download those, right? So that's causing a long time from request to response, right? Issue number 2, we're also seeing now, like I alluded to earlier, the design team actually wanted a blended image aesthetic. So that's why they're having 2 images that they want to blend. And even furthermore to the fact, we can see if we look down on lines 12 and 13 and 14, stuff like background attachment fixed, background blend mode overlay. These are computationally heavy effects that can maybe run well on your MacBook, but for lower end devices, it will be a bit of a GPU miss effectively to hit sort of the performance that we need. Okay, so we can try and simplify this. So what we've done is now in this case is we'll take out those background images from the CSS file, just get them out of there and simplify maybe some of the effects after some good conversation with the design team to see where we can find maybe a middle ground. We can then leverage in our HTML file directly some HTML elements that have been around for quite a while, but I often don't see this being used enough. And that is of the picture class or picture element. It's a picture element of which you can see, you can actually define a bunch of different images, which you see as the source. Those source tags there that have a type, we can actually deliver specific images for specific device viewports. So in this case, we've done our base image that the design team wants. We can add a picture element there. And the image that is going to be blended with to create that blended overlay effect, we can also pull that in. Now, secondly, I spoke about network priority earlier as well, right? How the browser decides what things to get first. Now, because this is an LCP issue that we're trying to solve, and we're trying to get to the LCP as low as possible, we need to request the images as fast as possible. So what we could do here is actually we can leverage what we call resource hints. That effectively says override the browser's default behavior of maybe treating this image as a low request resource and just add a tag called preload. You see on line 1, rel preload, and set the fetch priority to high, which effectively tells the browser to say, you're telling the browser, I need this now and fast. It's super urgent. So put priority on this image first. So we can apply it on the image our base image and our blended image as well. Once we retest, we see an interesting thing now that we can actually check out. And that is, firstly, number 1, in the block there, highlighted with the green block around it, the image has been promoted, if you will, to a priority of high, right? Which means the browser is treating this with urgency. If you look at our LCP score on the top left as well, that has gone down from 8 seconds to 0.3, which is a massive win. Why this is also a massive win is that if you look down, the image that we are serving for this device, and this was a mobile device we were testing on, or simulating rather, is that we are not downloading a 5K image for mobile. We are using a 1200 sort of width image, which suffices for that viewport and device pixel ratio, for example. So just leveraging that element, it made a world of a difference already. Noting that our big desktop displays that can accommodate it will get those 5K images as they need, noting that they're probably also on a Wi-Fi connection, which is fast enough to download. So we're good there. I think we're looking good so far. Cool. Secondly, we got another customer feedback that talked about content that was just jumping while they were reading. And we can see we're also not doing too well here. We want to be at 0.1. We're hitting about 0.25 and probably worse in other contexts. So let's sort of debug and see what's going on. We actually got a video we can look at. We're loading the page. Aha. It seems we've got a Black Friday clearance sale banner that has just popped out of nowhere and has pushed all the product sections down. That's definitely a cause for layout shift because we have just sort of unintentionally dynamically injected something into the browser, not considering that we've actually caused other stuff to shift in the layout. So how to actually spot this in the developer tools? There's actually another, when you see a layout shift occurs, there's actually another lane or track rather that appears called layout shifts, and it's sort of marked by a diamond. If you highlight over that diamond, what is great to see is that you can actually see the actual shift that is happening. So you can see the products are moving down, which is really great. So it gives us a very clear sense of where the shift is happening. And if you can see, probably there's a bit of an overlay, but down there it tells you that the products container was the element that was shifted. And that's contributing to the bad score you see at the top left. Okay, so if we escape this, now here's something we can maybe look at now. And this again, very simulation and example, but a common thing you guys can probably find is that you guys are probably working with marketing teams that use tools like Google Tag Manager, where there's some agency needed to dynamically or remotely add things as and when, according to either a business need or a campaign that's running, and you can't fully rely on a developer deployment. But often what happens then is that those scripts or HTML is written outside of the code base. You guys as developers are probably pulling that into your code base remotely as a script. And then it's causing a host of issues because the browser doesn't know about this dynamic content that's just been pushed in out of nowhere. So what we can see, for example, as a simulation here is there's a clearance banner that's injected. It's created in JavaScript with a couple of classes, some inner HTML that's written for the text and the copy. And an important one, line 20, it gets just injected before that product section. So that is the cause of what it pushes down that products container at the bottom, effectively causing the layout shift. So there's two ways we could do this. The one is to say reserve space. So i.e. in the HTML, maybe have like a div that's going to expect some height. So when things are injected, everything else does need to be pushed down. But again, that was a problem for the design team in this case, because if you create visible space, that's just negative space. Other things can just then naturally fall below the fold. So a second option we have is to completely remove this element outside of the document flow, position it like a fixed element that can overlay maybe something at some point, and then it doesn't have any bearing on moving any other elements down in the actual UI, so to speak. So in this case, what we could do is we could just set this banner to position fixed. In this case, we'll set it to the bottom. We'll index it above everything. And then we can use our compositor engine, which is nice to animate something off from the bottom to the top, and use a transform through translating on the y-axis into the page from outside. What that looks like in practice now, we can see, we can scroll our page, and we can have something like this, where it actually just overlays and it hasn't pushed any content down. Cool. So this obviously has probably fixed everything. So I think I'm keen to wrap this one up, but no. we see seems like our CLS score is actually worse, hasn't actually got better. We look again and we can see we're still seeing a lot of clusters of layout shift that are still present. If we cast our eyes deeper, it does seem now that we don't see that type of shift anymore. But we are seeing some interesting issues on the hero area. So that's the billboard that we had our blend effects and animations. And if you look at the bottom, there's a bunch of elements that are being declared as being shifted. So we've got like this premium light beam. And if we think about this is something that we did speak to the design team about. They wanted a very immersive animation experience on the billboard from a brand perspective. So we need to see maybe how we can potentially optimize that. Let's kind of just look at what this animation is. So it's this kind of glow animation that seems to be animating across the billboard area. And that is definitely can personally be quite computationally heavy for lower end devices. And it could definitely be a contributor to a bad CLS score. Okay, so if we look at this now, we've got some function that's going to instantiate this depth shader, if you will. And we're creating a couple of orbs, let's say circular orbs and light beams on the screen. And we're animating these across the board, right? What's important to know, though, is that here's the main culprit. On line 6 and 7, you can see we are using percentage-based positioning to actually align our various elements that we want to inject. In this case, we are using percentages for height and top positioning, which is not the best thing, because if you've got a parent container that hosts this element, and that thing for any reason is also dynamic and changes, and this also is a percentage of that parent container, the browser effectively has to recalculate on every scroll where this thing has to sit, because it has no fixed value. It actually needs to compute very dynamically where geometry sits. So that's going to probably kill a lot of things. The light beam as well, that yellow effect that you saw across the screen, is also susceptible to that percentage height and top. And we've got an interesting operation here where we're injecting all of these orbs and light beams into the hero section as well. A note here is that, because we spoke about the synchronous code earlier, JavaScript will actually append something with line 29, recalculate, 30, recalculate, and 31, recalculate. At some point, the browsers can be good in batching operations, but this could have that effect as well, which is not what we want. Okay, so the first problem we're seeing here is that we actually had this animation now of this light beam, and we were animating non-composited properties as well. So this is an important teaching point as well. When you're animating stuff like left, top, right, every time you sort of animate, the browser literally needs to sort of recalculate the position of an element. It won't just move something. It will actually just recalculate the position. It's a resource hog. Right. So what we could do here is that to fix the initial issue where we're having the percentage positioning problem, we can actually just fix this element, right? We set it relative to the viewport instead of the container. And then we can just animate using composited properties. So you guys have probably known about this. It's been out for a minute. But instead of animating left, you can use a transform to just translate things on the x-axis. And what the browser will do here, instead of relying on its recalculate style engine, it will purely say, hey, compositor, you're the one that does animations. You kind of just do that, and it kind of runs directly, also leveraging the GPU as well as underpinning for that. And then maybe extra credit, I would say, is from a principle perspective, one thing we can always think about, and I think it's important that we do this even from a design discussion or at the developer design cross-functional level, we have to think about progressive enhancement. Because maybe in this case, an animation is great on your 27-inch 5K monitor, but for mobile devices that are not as sort of great on the hardware front, you don't need an animation. Maybe we can just have those overlaid images. So in this case, you could leverage stuff like hardware concurrency, which is not perfect, but it is something to try out, where you can define that something is low end, And if it's a low-end device, you can just not show the animation at all. Another thing you can also, little known property I see talked about is that of the contain property. Effectively, in a nutshell, not to get too deep on this, but what you can do is that if something, let's say in the hero area where you had injected all of these orbs and light beams, if they are injected there, the contain property will tell the browser, if anything has affected me in terms of layout and style, constrain your recalculation purely to my container, my element. Don't worry about recalculating the entire page, the footer section, the product section. So in case, basically, in a sense, you make less work for your browser as well to do. So have a drum roll and see what happens. And I've now simulated very effectively now desktop and mobile specifically, where we're looking at our budget laptop and our sort of rural mobile category of device on the right. So here's something where we can look at now. If we've got an animation here on this desktop screen where we're doing a trace. And we can see our CLS score has basically gone down to 0. No layout shift at all anymore. Looking at our rural mobile device, this had now like a 10x CPU slowdown on a 3.5 megabits per second connection. I can see what's important here. No animation. We can still get the benefit of basic transitions and the overlay image, but we got the CLS down as well. So best of both worlds for both devices, using progressive enhancement to serve the right experience for the right form factor as well. Okay, and the last problem we're going to look at now is just that of another one that affects our INP score, or interaction to next paint, just to reiterate that. The support ticket that came through for this one was now that someone had clicked add to cart and nothing happened, and then suddenly 2 seconds later something appeared. We're seeing a base test of just under 2 seconds for INP. That's far removed from our 200 millisecond target or our performance budget. So let's maybe have a look at what we can debug here. Now, I want to note, unlike the other scores or other vitals, when you record and do a trace for them or audit, they can sort of suffice just to do a page load. But something like a INP issue is usually very closely tied to an interaction of some sort. So a button click, maybe potentially a scroll. But effectively what you want to make sure of is that in this case, you record sort of the isolated interaction and you measure at that point, right? So you're going to see this in sort of practice here. So what I'm going to do is I'm going to set my conditions for the rural mobile device at the CPU. I'm going to press record, or rather scroll to the section first that I want to record the interaction. I know it's add to cart. I press record, I click, and I see a spot change before that added text appeared. Something took a bit of a delay. And you can see now, as a result, now we've landed about 1,000 milliseconds, just about a second of an INP score, which is bad. So what we can do here now, actually, you can go into there and now you can observe finally this long task that took about just over a second with a lot of cascading functions and logic that we need to maybe see what's happening under the hood. So what we notice is here, if we just traverse down that task layer, we had an event click, and there was some event saying post analytics that's blocking the main thread. Upon further discussion, we've chatted with our development team, and we know that from the product and requirements, there was actually a key requirement that at every stage in the journey, you've got to send something to, for example, Google Analytics around where the customer is from a breadcrumb perspective, so we could have a bit of a richer engagement funnel to kind of see where the drop-offs and bounce rates are. But now in this case, it's actually got the net effect of actually just blocking the main thread. And when we say blocking the main thread, we are blocking the UI from actually updating on the visual side to the end user. Okay, so what's nice about what we can do in the DevTools as well, that piece of code that is blocking, it will actually take you directly to the line that's actually taking long. Now, in this case, purely for simulation purposes, what I've done is I've showed you, you can see on line 53, we declare sort of a post analytics event function. But there was a function on line 57 whereby this was simulating sort of some CPU heavy logic. This could, for example, maybe be the anonymization of personal information before you send data over to the server. That could be something like that, or any other computationally heavy hashing process, if you will, for security purposes. This code, as probably functionally sound as it is, if done in the wrong way, can actually block your main thread. So we can look here, for example, we had an add to cart button, event listener, and there's a click handler. Now, this kind of where the execution priority sort of talks to about those synchronous code tasks and micro tasks, etc. we spoke about earlier in the essentials. So one would expect here when you click for line 4 and 5 to execute, i.e. the text content will change to added, disabled will be state to true, and then this post analytics event will run. But unfortunately, because this is all synchronous code in terms of how the browser perceives this, it will actually wait for the entire task to finish before it paints anything to the screen. For example, the paint or the render step. Okay. So if we go to line 7, we can actually go into that events function now that will expose some of the code that we saw earlier. And there's our code there. Line 4, we had just a simulation of a while loop doing CPU heavy work. But one thing we can do now, remember I spoke to you about those on the execution priority, if you remember. On the last step, there's something called like basically other tasks that are not as important as the others. And those are tasks that are actually wrapped in a set timeout. So as a basic thing we can leverage is a set timeout, just like this. We can wrap that core CPU heavy logic and even the analytics event as a whole. Why? It's not relevant right now to the user experience. It can sort of kick off in the background as it needs to, right? Without blocking the core user interaction. We can do a set timeout and we can actually wrap the code in this that will actually effectively queue it and not block the thread. And then another small one that's also been around, but something you can also leverage is that when you post the analytics event, if there happen to be, for example, someone closing a tab or getting out of the session prematurely, you could actually persist that post of the analytics event in the background to this property called keep alive as well, which can also help you. So now let's review the fix. If we look at it, and we can see our INP has gone down all the way to 57 milliseconds, which basically means when you clicked add to cart, you saw an instantaneous update when you clicked add to cart and when the added was shown. No delay in the paint operation for the main thread. Okay. Now, what's important to note as well is that just because we unblock the main thread, that long task of the CPU heavy function is still there, right? So it hasn't gone away. It's been queued out of the main highway to sort of go on the side, while the core paint jobs of the browser are being attended to. So again, that is still something you could probably still address through stuff like maybe web workers or stuff that create additional threads. We can assign and delegate those tasks, CPU heavy things. So they still work. But in this case, we haven't put the cost or incurrence of the long task on the user end. Okay. All right. Okay, now we can just run another lab results test. So I'll go back into my application code and run that CLI Lighthouse tool. And we can see we've made a drastic improvement. Not perfect, but at least on the Lighthouse scores from where we were, things are looking good, just with those small fixes that we added on those core web vitals. A note I also want to make here is that also, like I said earlier, light scores are weighted versus desktop and mobile. But I think more importantly, all these tests that we are running on a cold cache simulation tests, meaning that there's no server-side optimization taken into account, no respect of cache control headers, revalidate headers, max age headers from the backend, CDN edge optimization that serve things quicker, or caching assets and so forth. So the idea is that when you fix things already at this point and things are looking this good technically at a cold start or cold cache level, you stand to gain so much more benefits once you really deploy the work and see the results in field. So just good to note. Again, just to reiterate, let your field or your RUM data, real user monitoring data, always be the primary source of truth. Your lighthouse, and that is purely for lab test results that you're using as a diagnosis tool to sort of do deep root cause analysis, triage, and fixing. Okay, just final takeaways we maybe just looked at, and I think these are stuff we can take a screenshot of or take note of. Try and use those inline images for those images at the top for faster discovery versus CSS backgrounds. Leverage resource hints like fetch priority to sort of tell the browser to sort of make a priority for key assets that you need. Use stuff like the picture element and source set to actually just use more progressive image sort of fallbacks to actually serve the best optimized images for the relevant form factor. Layout stability, if you're not going to reserve space on content, and then also importantly, if you're not going to do that with aspect ratio or min height values, try use position fixed and remove it completely out of the document flow to prevent any shifts for other content. Animation performance as well. Try and animate with transform, opacity, avoid the left-right sort of stuff that causes a lot of recalculation, very resource intensive. Use the contain layout style. And if you can, use stuff like hardware concurrency or even prefers reduced motion properties that you guys can research to kind of have a more of a progressive enhancement sort of aspect to your interfaces and products that you build, just to serve things where it matters and where there's enough resources or compute to actually make those effects actually look good. And then I think last one, INP performance, maybe just one big one. Just avoid those expensive tasks, even if they need to be done. Get them out of the queue. Don't let the browser, don't block the browser, the main thread, if you can. And you can use stuff like set timeout or some recent stuff that have been introduced for later browsers like schedule.healed. Okay, and as you noted, just to sort of also wrap up, we can still definitely do better. Or rather, I can say you can still do better. So there's a QR code here. You can probably just take a screenshot here. There's a GitHub repo, public repo. You can download this code base of TechMart and maybe see there's maybe more optimizations you can play with, as there's definitely a host of fixes that can still be done over and above the basic things that we tried to cover today. Okay. Overall, I think just generally to conclude from a performance perspective, especially in Africa, we've got a real long way to go. I spoke to you guys earlier about the Chrome UX report, of which there is a public API available that you can query that actually has some historical data. You know what I just did just for some oversight here was to look at 57 major business websites across Europe, US, Asia, and Africa. And I think it's quite challenging to see that where Africa sits on a regional basis in terms of average core web vital scores, we are quite low relative to, say, like Europe, for example. From an industry perspective, media industries are getting it right. Travel industries and e-commerce as well is not doing that well. But by and large, we at least are on a good trajectory across the board. I think ultimately it's important to know that we've got a role to play in making not only SEO better, but just performance better for our end users. I think we owe them that. And I think noting that the work you do for your end users that you do there, you will also sort of release the same benefits then, hopefully on the business end or for whatever your own KPIs or targets are that you're also trying to meet at your own businesses, your own companies, your own teams. Okay. I put a couple of resources here that I think Justin, I will maybe share as well offline. We can also just share it again with the forum. But ultimately, yeah, I think that concludes at least the key talk. I know it's been a long one. Hopefully you guys have got some value and we can take some questions.
Thank you so much, Jonathan. That was really, really great. If anyone has any questions, okay, here we go. here's one we have. I know this is a performance summary, but I'm wondering, seeing that this is coming from the African continent and the infrastructure can be meh, how often do you check with hardware concurrency for specs?
Okay, cool. On here. Okay, cool. Yeah, no, great question. I definitely think this thing is not being utilized enough. Right. So I would say, obviously, something like hardware concurrency is looking at a lot of logical processes. So if you've got a 4-core CPU that could have, for example, 8 threads, you could use that as a count. But I also know it's not the most reliable. So I think a lot of what sometimes you want to maybe use is your prefers reduce motion setting that can be activated. But broadly speaking, I think it's something we still need to champion more of on that front. I would definitely agree. I hope that answers your question or gives some context. Yeah.
Yeah, I think just to expand on that, we do a disservice to our users on the African continent a lot of the time. We just assume everyone's on this same lovely connection with their dev MacBook M4 or whatever. And whereas most people are on smartphones now, but low-end smartphones that don't have big JavaScript processing engines and everything like that. So I think this has been such a timely talk, and I'm very glad that you've done it. Apparently, the QR code is not working. Maybe you could just pop the link in our private chat, and I'll share it with everyone.
Okay, let me do that. Sure.
Okay, thanks. Okay, what else do we have here? Okay, AI. How does AI plug into this from a holistic point of view? I know you showed the new that Chrome has rolled out that little AI helper within DevTools. Should we be relying on AI for our performance testing, or is it just an additional thing we can use? Another tool, rather than it's AI is eating the world. I prefer to see it as just another tool. Yeah.
Yes. Great question. I think I'm agree with you as well, Justin. I think especially maybe contextually speaking to DevTools or performance-wise, a lot of what I've played with now, if you guys don't know, if you guys have played with MCP servers, you guys can actually set up, there's a sort of a MCP preview to actually go into the insights panel. But what that is largely doing is actually just doing a bit of a speeding up of diagnosis of issues to help you get closer to what to solve for. What I would say is maybe a better thing that AI is not doing well yet is that a lot of these conversations, even of what we try to do today to set up a bit of a stage, I feel these questions should actually happen way early up front in sort of the cross-functional process of when a Figma file is built, or when we choose a given framework that's going to use a lot of client-side JavaScript versus maybe leveraging more server-side rendering. I think that is where, I think Erastus had that question, is where we probably need to be marking the conversation and then noting that we've got quick tools to maybe augment quickly finding out root causes. But to get there means we probably missed a lot of conversations before that could have happened upfront and earlier in the value chain or product life cycle.
Yeah, great. Just to let everyone know, thanks, Jonathan. I've shared the link. It's in the chat. You should be able to access that. There are no other questions at the moment. I have one. First of all, thanks so much for going through all the methodology, kind of the theory behind performance, and then what do we do about it? Yeah,
sure.
For people who are coming to this perhaps for the first time, and they want to just start with a little bit of a performance improvement, what would you suggest is the kind of most impactful thing they should look at first? And not necessarily the easiest, but perhaps also the easiest. I mean, would it be like, let's look at our massive images that we're downloading as PNGs? Something like that. In your opinion, what's a nice way to get started?
No, definitely great question. So I think if you look at sort of the data, I think it's great for you guys to play with the Crux API, actually posing with BigQuery as well. But by and large, where most people are failing is on that LCP score, right? And the LCP is definitely about that early discovery of especially those core images and stuff that sit above the fold that actually gets you to an interactive page, or at least visually for your users. So I would say things that definitely affect that, the net impact of that is, again, looking at your images. You don't need to serve 5K images everywhere, right? We've got stuff like source set now that's been around for a long time. Get the right
Sure,
images for
forever.
the form
Yeah.
factor, right? When you guys are using a lot of maybe scripts in the head tag, it's very easy for us just to drop a bunch of scripts in our head tag, not knowing that every script tag that's seen there, once the browser comes across it, say for it being an async or deferred script, if you're not using async or defer, it will have to stop all the work it's doing and deal with those scripts now. So I think certain things
Yes.
like just hygiene about deferring your scripts
Mm.
at the end of the body
Mm.
tag, and sort of images and sort of serving the right images for the right form factor. I think once you get that basic stuff, LCP comes down, and then we can sort of take it from there as well. Yeah, maybe just at a high
Great.
level for you guys.
Yeah. Great. I've just shared Jonathan's LinkedIn info if you'd
Sure.
like to connect with him, because someone did ask for it. I'm not
Happy
just randomly sending out your.
That's cool. So I just seen like what,
um,
like a direct link to you, or maybe.
no, I've shared it.
Oh, you've shared it. Okay, perfect. Okay, awesome.
There we go. Yeah.
Sweet.
I'm very glad you mentioned the picture element. It's horribly underused. Yeah. I mean, I meet a lot of front-end developers who actually just don't know about it.
Yeah.
And I think okay, I don't want to be controversial, but I think our JavaScript frameworks mean we write less good old plain old HTML a lot of the time, and I think some of those nice things get lost along the way.
Yeah, I mean, to echo on that,
is
yeah. I think for a long time, and I think I was guilty of this for a while. We get very sort of accustomed to being sort of framework advocates, React developer, so forth, Next.js developer, and it's easy. And I think I don't blame anyone, because usually I'm sure, guys, in your workplaces, you are leveraging these frameworks because there's a lot of under the hood magic. It's sort of orchestrating,
exactly,
automating,
yeah. Mm-hmm.
limiting the scaffold, but at the expense then of you not fully understanding the internals.
Yes.
When it comes to optimization, you can probably even use the tools in the wrong way, which a lot of those stuff are actually hiding under the hood. Yeah.
I know you said upfront you didn't want to get into this framework, that framework, but I think it is an important point for performance.
Sure.
If you want to do a personal website where you basically have a blog, why are you using React for that instead of, say, Astro, for example?
Sure.
So also evaluate your frameworks up front. Yeah.
No, very much. And I think like you guys have probably known all the strategies around server-side rendering, client-side iteration. I think it's just finding also the just do the evaluations, and I think in the context of performance and your design vision as well, which is very key to this, as you saw today as well. Design's also
absolutely important, yeah,
right.
Absolutely.
How do you balance the trade-offs between great immersive user experiences that have the competitive advantage, but not sort of at the behest of like breaking everything for everyone?
A delicate balance. I've got a comment from Henri. That's interesting. I imagine that too much JS on a low-end device could be corrosive to the experience.
Yeah, very much.
We experience this a lot in Southern African contexts. Very much so. Yeah, I'm sure you can attest to that, Jonathan.
No, definitely can attest to. And again, it comes down to those head scripts. Every little analytics tool that we are posting things to, we don't need to do those while before the page loads. We can definitely defer those. So simple things like that, I think, does a long way for just quick time to render.
Yeah, exactly. And then another question: do you know of an African-based media site or e-com that has done well with performance in their environment? Takealot probably, or not?
Yeah, from what I've seen, at least the brief ones. It's a great question. Maybe I'll need to also get back to the forum on that one. But so far, what I'm seeing is that I think especially on those like the rural mobile cohort that we had with the 10x CPU slowdown and 2G network. It's not the best across the board. And again, what I think is happening a lot here is that, say for maybe using some progressive web app technologies, a lot of companies are actually building their mobile experiences for apps. So they've got an Android app or iOS app. So a lot of the redirection is happening actually to the app, where where the actual mobile browser or mobile specific UI or form factor for the web browser on Chrome, for example, is not yielding dividends really, because you got to get to your app that's compressed and G-zipped and all of those things, and that takes more megabytes to download as well if you want to download that Android application, or hopefully it's available on your Android OS as well.
Yeah, absolutely. Yeah. Oh, Henri, you're killing me. What's my favorite record? Oh, it's a different one every day. Right now, okay, this is completely off topic. Right now, it's this one. Okay, question answered.
Loving the artwork, actually.
But that's just because I got it last week. Yeah. All right. An aside. I think Takealot's the biggest e-com site in SA by users. Although I don't know what Amazon. We now have Amazon here. It's new.
Yeah.
I don't think it's getting much traffic.
I think relative would be, yes.
Yeah, I think people are looking at Amazon South Africa to find stuff, and then buying it on Takealot. Honestly. Yeah.
No, definitely. I think maybe one thing also just to highlight as well, you'll note also the talk was very much centered around client-side strategies, like those quick wins we can get. Because I have found more often than not, a lot of where work is happening to maybe increase performance is sort of setting up great configs on your CDN, distributing, serving at the edge.
Yeah,
a lot of those stuff that sort of kind of improve that time to first byte. But the thing is, if you got a great response time, you can still land up in the main thread at the paint cycle and make a lot of heavy work with a lot of expensive CPU heavy JavaScript and WebGL.
Exactly.
That kind of then just forfeits all the great work that may be done at the back end as well. Right. So another point there.
Yeah, definitely. It doesn't matter how great your infrastructure is if you, as you say, doing all the front end things incorrectly. Yeah. And vice versa, right? So you're doing all the front end things correctly, and then you're on like a shared server at or something.
Yeah. An experience. An experience has taught me it needs all that, I guess, that trifecta: product design, front end, back end, ops, to make this thing work. So I think it's very key that we all align at least on a common language as far as performance is concerned.
Sorry, I'm just replying to comments as they come in. I couldn't actually speak. I forgot.
Yeah, no worries. Yeah, I'm also just trying to go through it. Let's see. Okay, there we go.
Does the newsletter focus on the African perspective? To some extent, we do share a lot of stuff that comes via your standard stuff that gets written globally. But we have a strong focus on promoting our past talks that we've done, which usually we try and have a local focus on. Specifically South African, and then we also, have job listings that are geared towards the local community, events and things like that. But we do share articles that might appear on, CSS tricks and things like that.
Yeah, one thing I did see, Justin, there was a question to make the slides available. Yeah, so I think I'll be in touch with you to I just need to export a couple of things.
Okay, great.
Everything we can get the hands of the attendees here. Probably valuable.
Perfect. Great. What we can do is, this will be archived on YouTube, and we can add the link to the YouTube description. And then I've posted our Discord and our newsletter links. If you join the Discord, we always post all relevant things related to post the talk, if you want to rewatch or share, and if there are any slides or links, please feel free to do that. Yeah. All right. Great. And that was fantastic. Thank you so much. I think people have learned a lot from your talk. And I think you've given a great starting point for starting to think about performance and why it matters and what you can do about it, and particularly in our context.
Great stuff. Great stuff. I think I thoroughly also enjoyed this time to engage and also hear from you guys. So hopefully it brought some value. And I think, again, a primer to get you guys started on the fundamentals and the basics, for sure.
Yeah, absolutely, because you can really go deep into this. Great. Thanks everyone for joining us tonight, and really nice to have some folks joining us from across the ocean, so to speak.
Fantastic.
Very nice. Welcome. We do these once a month, sometimes twice a month. You can join our meetup, join our newsletter if you want to stay apprised. Henri from Canada. Right. Welcome, Henri. That's great. And we will be doing one more event this year before everyone kind of shuts down for the Southern Hemisphere summer holidays. And that will be in the second week of December. And it's going to just be Skulk and myself just doing a recap of what we think are important things that have happened in the front-end and design world this year. And then we will resume again in January next year. As always, if anyone is interested in giving a talk, you're more than welcome. Anyone, it doesn't matter what your experience is. We encourage anyone to get involved with starting to give talks, and just get in touch with us via the Discord or Meetup or however you can. LinkedIn is fine as well, and we can arrange that. Yeah. Right. So, thanks again, Jonathan. Amazing stuff. Thanks to everyone who joined us, and we'll see you at the next one.
Awesome. Thanks, everyone. Appreciate it. Thank you.